There are two strings, one is shorter, another longer. The challenge is to know if the longer string contains the shorter string in any order. In this video, we're going to see how to solve this problem, which is LeetCode question 567 using the sliding window technique. So here's the question itself. It's called permutation in a string. The question reads, given two strings S1 and S2, return true if S2 contains a permutation of S1 or false otherwise. Now we're going to see the main ideas of how to solve this problem. Now let's take a look at an example. We have S1, which is a shorter string, AB, and we have a longer string, S2, which is this one. And we want to find if S1 is present in S2 in any order. The output is true because we matched BA, which is the opposite of AB. We found it. The order does not matter. So in order to do this, we're going to use the sliding window technique. We're going to use a sliding window, which is a fixed sliding window, which has a length of just the length of S1, in this case 2, because we have 2. And then we use that sliding window, which has a length of 2, and we will slide over S2 one by one. As we do this, we're going to keep track of a few things. The first thing that we're going to keep track is the difference between this S2, the window, and then what we want to find, this AB, this S1. So as we move along the sliding window, we're going to keep track of the difference between that window and then what we want to find, S1. So that's the first thing. The second thing that we want to do is the sliding window itself. We're going to expand the window using a variable called add, which corresponds to the right pointer. And we're going to remove or shrink, or because we have to keep track of only the fixed window length. So we're going to move the left pointer, which is remove, as we move along. So that's the second point. The third point is we also have to keep track of a variable called matches. When matches is equal to 26, we have a permutation present inside our string, and we're going to return true. So we will see why this is the case in the animation just in a bit. Now let's take a look at the animation. So we have two strings. S1 is AB and S2 is this long string. The first thing that we want to do is we want to create what's called a difference table. So difference table, in English we have 26 letters, and then for each letter we're going to create one slot. So A all the way to Z. And then the first thing that we're going to do is we're going to subtract what we want to find AB from in this. The frequency needs to be subtracted. So for example, because we start with AB, so we give A -1, B -1. So we subtract it from this table. And then we're going to add whatever we see as we slide in this long string one by one. So we start from E and then I. We keep the length of 2 because this is fixed length. That length is equal to A and B. So we add E and I first. So E is equal to 1, I is equal to 1. So in total, we have 4 things that are different out of the 26. So A, B is different, which is negative, and then E and then I is different, which is positive ones. So in total, we have 4 elements out of this 26 that are different. So we are matching only 22 out of 26. 4 are not matching. So now we're ready to slide our right pointer from I to include D. Let's slide it. As we slide it, so D is a new thing, so we're going to add that into it. So now D is added. So in total, 5 things are not matching. So matches is going to go down to 21 out of 25. So now the length is 3, so we have to move the left side to make it length of 2, and then move the left pointer to I. When we do that, E is going to be reduced. So E is before 1. Now this 1 is going to go down to 0. So let's move it. So E went down to 0. Now overall, we have 4 things that are not matching. So matches is 22. So now we're going to move the right again. So we move the right by 1. Before, this B was -1. Because we are adding that in, so this B is now going to be positive. It's going to be 0. So we're going to move and include B, and then now it became 0 from -1. So now we have 3 things are not matching in overall 26 out of 23. 23 are matching, 3 are not matching. So now because the length is 3 again, we're going to move the left by 1 to D. So when we do that, this I, which was 1 before, is going to become 0. So now it became 0. Now out of 26, we only have 2 things are not matching. We keep going. B is going to move to A. B, this A before was -1, because now we're adding A, so it's going to become 0. Now we're going to move it, include A, and then A became 0. We only have 1 thing that doesn't match out of 26, now matches 25. Because this is 3 again, we're going to move left to 1, and then now it's going to move, and then BA is the only thing, and then everything became 0. So we have 26 out of 26. Status is going to be changed to found because all 26 are matched. And then we found our match, and then there's a permutation that exists. So that's the entire logic of this problem. Now we're going to see how the actual code is written. Now let's take a look at the code. Let's start from the definition, check inclusion. So we start from S1 and S2. S1 is the smaller one, S2 is the longer one. The first thing we're going to check is the lengths of S1 and S2. If S1 is longer, we're going to return false because S1 needs to be shorter. Okay, so next we're going to store S1's length into a variable called m, and we also create a difference table. So this will create 26 slots, 1 for each of the letters in alphabet. There are 26 alphabet characters. That's why we will do this, to create the difference table. First of all, all 26 will carry just 0. It starts from 0. Then we're going to subtract S1 from this difference table. To do this, we're going to loop through each character in S1 from the shorter one. And then we're going to first convert that character into a number using this. We subtract 97 because A's ASCII number is 97. What we'll do is it will convert letters into a number from 0 to 25 because there are 26 characters, and then Python is 0 based, so we will do this and it will convert it into 0 to 25, 1 corresponding to each letter. So first of all, we're going to subtract S1, and from the difference table, the count will go down for the S1 characters only. So that's why we do -1. And then for the first window in S2, the longer, because we're going to add the frequency of those, whatever we see in S2. So we're going to loop through the first window, which is m, as m corresponds to the length of S1. And then we're going to add the frequency into the difference table. So we'll do the exact same thing, convert that into a number from 0 to 25. And then whatever we see in S2 in the first window, we're going to increase their frequency by 1. Okay, so those are the first initial states that we're going to do. And then we're going to create the matches. So matches is going to be going to keep track of the entire match. If matches is equal to 26, then we will say return true. It's going to be there is a permutation inside a window. This sum 1 for x in diff, if x is equal to 0, basically sums all of if the cells are equal to 0, basically it means matches. It's going to convert that into 1, and then it's going to sum all of them. So if matches is equal to 26, then there's a permutation. So the matches is going to keep track of all of the matches inside our window. Okay, then we're going to slide using the right pointer, and then using the left pointer. We're going to add using the right pointer and remove from the left pointer. So the left pointer is going to be 0, and then for right pointer, this is what we're going to expand using R. From range M, we're going to start for M, and then all the way to the end of the S2. As we expand, we're going to create add. So this is the right pointer's corresponding variable. And then we're going to convert that into a number. As we expand one by one, we're going to convert that into a number. The left side, the removal part also be converted into a number, which corresponds to the left pointer. And then we're going to add. We're going to do first check the state. If before even adding this step, we're going to check if there's any matches. If the character is matching before, we're going to about to unmatch it. So we're going to reduce the match state by 1. And we're going to add that. The count will be increased. And then we're going to check the state again. So if it matches after adding it, the matches will be increased by 1. So that's the add part. And then on the left side, we're going to remove it. The logic is exactly the same, but we're going to reduce it. The difference will be reduced. So remove. So we're going to check this state. If it was matching before, we're about to unmatch it. So we're going to remove it by 1. We're going to remove it from the count will be reduced. And then we're going to, after a count is reduced, if the matching state is matched, we're going to increase match by 1. So we're going to check the state. If it matches, we're going to unmatch it, and then we're going to remove it, and we're going to check the state again. So this is the most confusing part, but after you think about it for a bit, it's actually quite easy. And then we're going to move the left pointer by 1 because we are moving on the right side, and we have to move to keep this state fixed window state. And at the end, we're going to, if this match is equal to 26 that we talked about before, we're going to return true. This means that we found the permutation. If not, this whole thing does not find anything at the end, we're going to just return false because we did not find any permutation. And that's the entire logic of this solution. That's the end of today's bit-size DSA video. Hopefully you learned a lot. In our next video, we're going to continue to learn new patterns that we can use in solving LeetCode problems. So stay tuned. If you like this content, please subscribe and check out other similar videos.